folks, so I wanted to pick a few problems out of the homework section 4.3 that might cause you a little bit of trouble. You probably get through them just fine without me, but just in case. What I want you to notice here for this particular problem, a couple of things. It says find the exact value. Now, you're going to learn, maybe you have already, maybe you haven't, but anytime you see find the exact value, that means don't touch your calculator. Your calculator gives you a decimal approximation, and in a pinch, it gives you close, but it does not ever give you the exact value. So if you're searching for exact, no calculator, don't touch it. So we've got to figure out a way to handle this. Oh, look. It even says over here, do not use a calculator, okay? But again, if it doesn't say that over to the right, exact value, you still don't use a calculator. Now, when you look at cosecant of 27 degrees, I don't think about anything but calculator. 27 degrees isn't one of those standard values on our unit circle, right? So if I've got something that's not like pi over 4 or pi over 6 or those regular guys, 30, 45, 90 degrees, then there's got to be a trick. There's got to be some kind of trick to get the job done. And in this case, it's a cofunction trick. If you'll notice, cosecant and secant are cofunctions of each other. And you learn about cofunctions in section 4.3. And for instance, they're related by 90 degrees. So you could say, right over here, I'm going to rewrite the cofunction. Cosecant of theta is equal to secant of 90 degrees minus theta. And all the cofunctions are exactly the same, so you can switch these out. So sine and cosine work this way, tangent and cotangent work this way, secant and cosecant work this way. So here's what I'm going to do. I'm going to replace my cosecant right here with this. So cosecant of 27 degrees is equal to secant of 90 minus 27 degrees, which is secant of, how convenient, 63 degrees. See how this works? And so, replacing the cosecant of 27, did I say that already? So it's going to be secant of 27 degrees times, there's already, 63 degrees. Times secant of 63 degrees minus, okay, now it's still not looking all that great, just hang with me, okay. Now tangent and cotangent, I know they're cofunctions of each other, right? And for some reason I like tangent better than I do cotangent, so I'm going to use the cofunction for cotangent. I know that cotangent of 27 degrees is going to equal to tangent is cofunction of 90 degrees minus 27 degrees, okay? So what is, I'm sorry, I got distracted. 90 minus 27, okay, same as 90 minus 30 is 60 plus 3 more, so tangent of 63 degrees. Now I'm going to substitute. So I already have tangent of 63. We didn't do anything with that, but I'm removing cotangent of 27 because I found out it's also tangent of 63 degrees. Now for space purposes, I'm going to erase all this work to the right. So it's about to disappear. Poof. It's going with the magic eraser. Almost gone. Give me my space. It's gone. Okay. Now what do we do with this? Does this look like anything that you can do something with? What do you think? When I look at this, I see secant of 63 times secant of 63. There's two of them. So that's secant squared of 63 degrees. Tangent of 63 times tangent of 63. Aha! I have two of them. That's tangent squared of 63 degrees. Parentheses not required. They just make me feel better. Now, I still don't have an answer, right? Secant of 63 degrees is still something I feel like I need to plug into the calculator. But if you'll remember, and I'm going to change colors on you because I need space. This, whenever you have trig function squared, you should have a little light bulb that goes off in your head that says, oh, this is probably a Pythagorean identity. What do you think? Well, I think I don't ever remember the blasted things. So I start with the guy I know, sine squared of theta plus cosine squared of theta is equal to 1. And then I transform it. Now I want to transform it into where I have a tangent. The only way I'm going to have a tangent is if I have a sine over cosine. So remember the trick. If you can divide each of these by the same thing, you'll probably get another one. So if I divide each of these by cosine squared, I'm sorry, y'all, divided by cosine squared, divided by cosine squared. Now, where does that take me? Sine squared of theta divided by cosine squared of theta. What does that equal? That equals tangent squared of theta. So that's tangent squared of theta plus, of course, that's 1. 1 over the cosine is secant. So 1 over the cosine squared is secant squared of theta. Now, look, that's similar, not there yet. How do we get a secant squared minus tangent squared? Subtract that dude to the other side. So I have 1 is equal to secant squared of theta minus tangent squared of theta, and boom, there I go. So secant squared of 63 degrees minus tangent squared of 63 must equal 1. Isn't that awesome? I know you don't agree, but it is, okay? So we used the cofunction identities, we used one of my favorites, the Pythagorean identity, and boom, we did all this without a calculator. Let's try another homework problem. Okay, if theta is an acute angle and cotangent of theta is 1/4, they want us to find cotangent of pi over 2 minus theta. And this is a thinker right here, and maybe this is not what they had in mind, but I'm gonna process it the way I process it, and we'll see what we think about it. So we have an acute angle, and this is the triangle section. So you know what? I'm gonna draw ourselves a triangle. There we go, and here's our angle theta. Now, what do we know about cotangent of theta? Cotangent of theta is defined to be adjacent, right? Is that right? Over opposite. Now, how do I remember that? I remember tangent. Tangent of theta is opposite over adjacent. Cotangent is its reciprocal, so that's adjacent over opposite. So if I label this triangle that 1/4, my adjacent side is 1, my opposite side is 4, right? You with me? So I'm thinking backwards. I'm taking my information they gave me, and I'm creating a triangle out of it. So I'm working backwards. This won't be the last time you do a trick like this. This is the first time I've seen it, though, in this section. So anyway, you've got opposite is 4, adjacent is 1. You could find hypotenuse by using the Pythagorean theorem, right? 1 squared plus 4 squared equals c squared, and solve for c, but we don't need it. Here's what we need. We'll change colors on you. Pi over 2 minus theta. Where's that on my picture? Right up here, right? That's pi over 2 minus theta. Remember what cofunctions mean? The co in front of your trig function? It means complementary, and complementary means they add to 90 degrees. And anytime you have a right triangle where this dude's 90 right here, then these two add to 90 degrees, always. And we're not using degrees, we're using radians, but this one plus this one is going to add to pi over 2, which means the other one is always pi over 2 minus theta. Okay, so I'm supposed to find cotangent. So the cotangent of that angle, pi over 2 minus theta, is going to be the adjacent over opposite. Now that's in terms of this angle. So the adjacent side is 4, and the opposite side of this angle, remember straight across, is 1. So the answer to this in my argument is 4. And there may be an easier way to handle that. I know you're looking at it going, yeah, we just flip it upside down, but I had to work my way through it logically and make sure that makes sense. Will you always flip it upside down? No, just work through it logically, right? You got this. You got this. So recreate your triangle, find your pi over 2 minus theta angle, which is the other side, and then set up your trig function. You totally got this. Let's do one more. Okay, folks, so my last question is one of those end thinking questions. So we're just going to think our way through it. Now, these are multiple choice, and I didn't even look at the choices. I just want to talk about this setup, and you can take this information if you watch this video with you and see if you can answer the multiple choice questions. If you still have a question about it, let me know. I don't even remember what the choices were. But it says, determine whether the statement makes sense or does not make sense and explain your reasoning. It says, for a given angle theta, I found a slight increase in cosecant of theta as the size of the triangle increased. Now, I kind of question what they mean by the size of the triangle increasing. Call me a dummy, but I'm not really sure what they're talking about. So, I got a triangle, right? And I'm assuming this is the angle theta that they're talking about. Okay? Now, they're saying like the size of the whole triangle? Like if I give a bigger triangle, y'all, you think that's what they're talking about? You keep the angle theta and you just make the triangle bigger like that? Okay, we're going with that. I can always go back and look at the answers and see if that's truly what they're talking about, because they didn't say anything about the angle increasing. They said the size of the triangle increasing. Okay, so that's what we're doing. We're saying this triangle goes to this triangle. Theta stays the same. Now let's think about what is cosecant. Okay, so cosecant of theta, remember your definitions, cosecant of theta. First of all, what my brain does is that's a reciprocal, right? Cosecant is the reciprocal of sine. Sine is opposite over hypotenuse, so the reciprocal of that is hypotenuse over opposite. Okay, so cosecant is hypotenuse. Here's hypotenuse over opposite is right here. And so in this picture, you got hypotenuse over opposite. Now, my argument is that as the triangle gets bigger, the hypotenuse gets bigger, and so does the opposite get larger. That angle stays the same, right? Isn't that what they're saying? If the size of the triangle gets bigger, it didn't say anything about cosecant getting bigger. So my argument is that cosecant is going to stay the same because it's a ratio of hypotenuse over opposite. And since the angle's the same, it shouldn't matter. Okay, so that's all the homework help I have. If you have any more questions about these, if that last argument didn't make any sense, or you missed that problem, or you want to see others, you just let me know. I hope you have a wonderful day. Bye.